of you. Today we will learn how to prove synchronous speed of induction motor. You know all of this formula. Synchronous speed of rotating magnetic flux of induction motor Ns is equal to 120 F by P. This Ns indicates speed, synchronous speed, that is rotations per minute of rotating magnetic flux in an induction motor. 120 is a numeral, F is a supply frequency, given supply power supply, P is the number of poles which is of a given induction motor. It is permanently this parameter is indulged in a induction motor while manufacturing itself. This frequency can be varied, of course, but fixed frequency in general will be 50 Hz somewhere. Now this is the synchronous speed. We have to prove the synchronous speed of rotating magnetic field in a induction motor. Ns is equal to 120 F by P. So before going to this chapter, we will learn about some parameters. Let's see the waveform of a supply frequency. This is the waveform of the supply waveform, that is flux or current. Current or flux, it implies same. That is, there is a not exactly, but it flux waveform will follow the current waveform. We all know in our textbooks, exact but not exact, but it will implies there is no difference between the major difference between the flux waveform or the current waveform. It will follow, the flux waveform will follow the near about the current waveform given supply. Okay. Now if you see deep into this waveform, this is the time period of a cycle. This is taking a one cycle starting to starting value. This is the waveform. Now here to here, this is the time axis and it is the value magnitude of the current axis. Then this is the time period of one cycle. Time period of one cycle, we all know that time period is equal to 1 by F, supply frequency. So that implies that half of the time period will is 1 by F divided by 2, that is 1 by 2 F seconds. So now we have to prove firstly the time rotation of magnetic flux in the induction motor having P poles in half cycle of supply cycle, that is 1 by 2 F seconds. In 1 by 2 F seconds, what will be the rotation of the flux in degrees, mechanical degrees, 360 degrees by number of poles. So we have to prove, let us prove the first prove this 360 degrees by number of poles. First, taking a 3-phase induction motor of RYB phase, let us learn about the taking a single R phase. So we can take any phase, of course, but taking a R phase, this is the north pole of 2-pole means this is north pole and this is starting this is winding, this both ends are the winding in R phase, starting and ending. This is entering and this is leaving. For first half cycle, this will be the, suppose let us say the first half cycle, it is the north pole and this is the south pole. In the second half cycle, of course, the current will reverse and the poles of polarity of the magnetic flux also will change. This will become north and this will south. So in a half cycle period, the magnetic flux will travel, will shift to north. Here is north pole is shifting to here, this south pole position, near about 180, exactly 180 degrees in half cycle. Means this polarity here change, half cycle into polarity change. So in half cycle, the flux is traveling to, taking one north pole, single pole, for example north pole, it is traveling about 180 degrees. So that is 180 degrees means half of the 360 degrees. So half of the 360 degrees, 180 is equal to 360 by 2. Here the 2 represents the north and south pole, that is 2 number of poles. Similarly for 4 poles, 360 degree by 4 means 90 degrees. The pole will shift to the adjacent pole in half cycle. That is, here if it is taking 4 poles, it will travel to adjacent pole here, that is 90 degrees only. So in commonly we can prove that, we can say represent commonly angle traveled by a pole to adjacent in half cycle, that is means 1 by 2f seconds, 360 degrees by p. It is a common formula. So you have proved that a pole traveling to its adjacent pole in half cycle, that is 1 by 2f second, is equal to 360 degrees by number of poles. So coming to the main topic, here I am telling I am taking that the time taken for magnetic flux, that is one pole to rotate in one cycle, that is 360 degrees. The time taken to rotate, complete one rotation for one taking one pole to complete one cycle is equal to time period of half cycle of supply current traveling in half cycle period multiplied by the angle transferred or angle traveled in a half cycle. Angle traveled 360 degrees by angle traveled by the in that particular half cycle. Half cycle 360 degrees by angle traveled by half cycle. 360 degrees, what is the angle traveled? We have proven here. 360 degrees by number of poles. If it is 2 poles, then it will travel 180 degrees. If it is 4 pole, it will travel 90 degrees. Same here I represented. So means half period of the cycle means, half period means 1 by 2f seconds. 1 by 2f seconds multiplied 360 by 360 by p. 360 cancels and p will come to numerator. 2 by this is equal to 2 by f seconds. So time taken for one rotation is equal to number of poles divided by 2f seconds. I written here same. Time taken for magnetic flux to rotate one cycle, that is 360 degrees, is equal to p by 2f seconds. So this represent for one cycle how many rotations? Is equal to 1 by 2 p by 2f becomes 2 by 2f by p rotations. For 1 second 2f by p rotations. So for 60 seconds multiplied by 60 into 2f by p, that is 120f by p rotations. This is nothing but the 60 seconds means rotations per minute, synchronous speed. Time taken magnetic flux rotation means synchronous speed of rotation of magnetic flux is equal to 120f by p rotations. I think you will get you will may get some clarity by this explanation. If you like this video, like it or share it. Thank you very much.